Back at it again with the new parts. Every order I put, I think is going to be my last order. There's always another last order. Last video, talked about the things I was waiting on. All those things came in. I have a new pulley. I got my fan installed. I was dealing with the rear main bearing, and I used Ford Barn. I chatted up a storm with some folks. One guy actually gave me his number, and I called him. But I had found some fiber in the oil slinger, which I'll put a picture of here. I think the leak was because of the rear cap fitment, and since I've been back in there and retorqued it, that cap fits pretty good. And I know a lot of people say just good. Hey, the compression's good. Blew my thumb off. No, I put plastic gauge in there. Yes. All my bearing caps were between 1 and 1.5 thousandths clearance. Here's a look at the oil pan. Got all new bolts, new gaskets, cork seal soaked in water for 3 days before I installed this, and the rope seal soaked in oil for over a week. I've got about 3/4 of an inch of clearance in my radiator here. These hood rods will be adjusted once I get the hood back on, but that should be fine. I got new hoses. This piece of safety wire is holding my thermostat down here at the bottom. I might put a clamp on there later, and I've heard that I might even struggle with these clamps. So what I'm going to do the first time I fill this radiator up, I'm going to use straight water from the garden hose, because I know I'm going to have a leak, and that way I can drain it right back out, fix my leak, not make a mess with coolant. Most of the remaining work I have to do on this engine is on this side. Model A, as a mechanic, I am so spoiled working on this car. There's so many vendors available. The parts are cheap. Some of the decisions you have to make are like what I ran into here, which was a mistake. I ordered timing cover bolts twice from 2 different vendors, 2 different times. I forgot I'd already ordered these. They were so cheap and insignificant. But in my last order, I got these black ones. I'm going to use these black ones, but dude, how spoiled can you be that you're going to choose the color of bolt? I know it's just probably because of the times we're in. It seems everything I've ordered takes another week, 2 weeks, when other things I've worked on in the past might be a factor of days. If I miss something today, I'm going to be waiting another week, just guaranteed. Timing cover gasket was keeping me from putting oil in this engine, which I'm excited to find out if my oil pan's leaking. Sometimes I like to stop halfway through to make sure it's not going straight on the ground. Level on the ground. So we're right now 3/4 full or quarter empty, depending on how you look at it. Dry fit this manifold. No gasket, just to make sure that everything fits. It's a brand new part. Oh yeah, we're looking good. There is no space. Well, this is a very important step, because you will get an intake leak if you don't take the time here. We're looking for this to be flat all the way across. This old manifold was flat, but it did not have proper alignment across these holes. All these holes should be the same. With it loose, you can move it a little bit. And I'll show you why I abandoned this one. Right here, this ear has been brazed. This is the most critical one. I had an exhaust leak here. I looked at the gasket and I could tell it was leaking there, but I'm just not comfortable putting this back on and going thousands of miles with it. I like brazing. The guy did a good job that worked on this car. But there was another issue here, and where these bolts go, there is a little casting knob, which you could see if you had a flashlight done in there. One of those broke off. So I have a hole that I was going to have to patch. That's strike number 2. Okay, we're just going to draw this down, finger tight, flip it over and check our heights, because if these were ever machined together to make this surface flat, which has been done, and I'll show you my problem now. That intake probably 1/16 of an inch too low. Just let me show you better what I'm dealing with here. That old manifold had been machined with the intake on it. So now that I've got a new exhaust manifold, my intake manifold is got a huge gap there. I think, this is crazy, but it is less than this gasket. So I think what I want to do here is use a standard exhaust gasket and then drop one ear of this on each intake. When I pull this up, it will pull the intakes down a little bit. The real correct fix would be to remove it here from this pedestal and machine this down the thickness that I'm missing here. But I've got to move this car today, so I may come back later and do that. But not today. Put this gasket on here and line it up with the exhaust port at each end. Here and here. And we're checking our intakes to make sure that they're centered. Just gotta go down just a little. Check it again. Okay, this should seal up. Intake spacer, we'll call it, instead of gasket. Right there on the intake stud. Now, I'm breaking my own rules here because I know when I do something like this, I'll be back fixing it. But just be easy on mechanics because you never know why they had to do something. If you see something weird, give them a break, give them the benefit of the doubt, because I will go back and fix that. But I've got to move this car today. I've got to make money. And it's blocking my welder. And it's been in my garage for 2 weeks. Not that I'm in a hurry, but yeah, it's time to get this thing driving again. There's a radius. Make sure the radius is out. So the concave side is inboard. So I've gone through here and gotten all these kind of snugged down. And I worked across here randomly, started from the middle, worked my way out. None of these studs are pulling more than the other at this moment. So I've got the slack out. What I'm going to do is back off on this intake a couple of turns. That way we're not deforming this, but also we're holding it in place with the stud tension. Look at that, busted my knuckle. So German torqued already, they're good and tight. A lot of folks will put sealant on this flange here, which I will do after I break this new manifold in, get it hot a few times. Good. While I'm tightening up this Tillotson, I just want to talk about Tillotsons for a minute. Everybody picks on them. You know, I know it's a few little extra problems that you might not get with that cast iron one, but I'll be honest, these are fine. The torque here, you know, you need to get it snug, but don't crank down on this. That's what tears them up. You know, you tighten down this flange. Heat cycling will also make these things warp, so you want to get it snug where it doesn't really have a chance to move much. But you also don't want to go yanking these threads out or putting tension on it for it to get hot. Matter of fact, the way I straightened this was putting it in the oven. I put a hose clamp right around here and heated it up at 300 degrees for like 2 hours and let it cool. And this gap closed up completely. So they're worth fooling with. They run pretty good. And everybody talks about it being pot metal, like that's such a horrible thing. I wonder how close we were to having all pot metal, or, you know, alloy as I'd call it. It's not as insulting. Alloy carburetors, because one of the obstacles that the engineers had to come through when Henry Ford was designing this is all hearsay, what I've heard, what I've gathered, but he wanted 1 bolt to hold these carburetor halves together. And this is 3, if you notice. There's no way you could make this hold together with 1 bolt. It can barely do it with 3. So maybe that's the reason they're cast iron. And very often it seemed like a carburetor was selected over price versus practicality or longevity. It just so happens that, you know, we're looking at these things 90 years later and we can't argue the longevity of them at that point. It would have cost Henry Ford like $1 more. So you get the Zenith, and they work fine. All of them work fine. Things are running. What more can you ask? This is a very old mag timer. I've had this kicking around forever. So it's powered just like a test light, except it's a noise. So I have the point set to open. We're at top dead center, checked with the pin, verified with the piston. Okay, the buzz box right now is telling me that the points are closed. I'm gonna pull just a little bit on my advance lever. You can hear the change. We're right at the very top. You can't get any better than that. Getting real close to the moment of truth. I've got just some oil in a syringe. Put a little bit of oil in these cylinders. The reason I put oil in there is this engine's been sitting with the head off for a couple of weeks, and I use brake cleaner to clean all that gasket off. Pretty sure all the oil has washed away from the cylinder walls. Also, it sat with the oil pan off for about a week, so I know all the oil's drained down to the bottom. We've got the plugs out. We're going to crank the engine over with no load to get some of that oil circulated. Crank bearings get they were clean, spotless, so let's get some oil circulated through the engine. Okay, opening the throttle all the way. All right, so I just filled up the radiator with the garden hose. We've got our first leak right here. So let's tighten that up. Okay, there's one. Also got water leaking at the packing nut, which is to be expected. I haven't tightened this yet. Let's put a little turn on that. I really like to crank the engine and turn that, and like I said, we'll do this again once the engine's running. We'll just put a little turn on it for now. Oh yeah, way loose. All right, looking at my list, I've got everything in there: oil, water, fuel. We stopped a few leaks already, and I expect some more, especially at this water pump, packing, and maybe this temperature sensor. So it says my plan was to start it and run it for 15 minutes, let it cool down, retorque everything. So my battery's on. We got fuel flowing now. Just one more check, make sure puddles of water there. Just gauging the size of them. All right. Neutral. Sparks retarded. Full oil throttle in. Hang on the choke. All right. Ignition is on. Close. Careful around this fan. I see it beating up back here water-wise. And it's still going. Love to see that good oil pressure. Funny, I've got the right tool for this job, but sometimes the wrong tool is easier. Running about 5 minutes here. I want to talk about my gav because before I never could bring it in past 1.5 turns. You can see now that's fully closed. I'm opening it real quick. That's a quarter and that's a half open. Still kind of cool, so I'm in the right range now. That's a full turn. This is good. This is an improvement. Radiator's starting to make a little heat. You can see down in there. Thermostat hadn't opened yet. This is still cool. Warming up nice. Oh yeah. Scared me, but it wasn't hot yet. You can hear it, the exhaust. Sweet. Finally running good enough where I can tell what the timing lever's doing. Let me put a little throttle in here. All right, and just listen. Move that out of the way so you can see what I'm doing. I'm gonna retard it. Hear the RPM slowing down? Let me go and advance it. Picking up a little bit. Still going. So my sweet spot in there, for that RPM, right along in there. Did y'all, can you see what I'm saying? Alright, I've been running it for quite a while. So my oil pressure, ball oil, seems low, but I'm not going to worry about that. What I'm going to do is shut her down, let it cool off, torque that stuff. I'm going to have to drive it most likely to get it up to temp. So maybe you look in the next video, I'm going to do a compression test again, see how much change we've made with the high compression head.